Hello, here is Michael Pulin. Today I would like to introduce you a pattern of distributed transactions for microservices, the business case for it. It's a part one of 5 parts presentation on this topic. For many years, technology tries to resolve a contest between business operational logic needs and technology means available for that logic implementation. Ideally, the business and technology are supposed to work shoulder to shoulder, collaboratively, and the only challenge in this case is the proper functional governance across technology and business units. Instead, as a result of centralized IT, which was reasonable initially, we have a situation where centralized IT started to impact business negatively, slowing it down in the dynamic competitive advantage of modern market. Nowadays, with microservices that are set around business functions rather than around databases and networks, we see an accelerating competition between business and technology. Which one will drive the company forward? The technology banner is about scalability and speed in development that are gained for the cost of either lost or incomplete data. Unfortunately, technology is still unaware of business concepts, trading rules, business meaning of efficiency and success, which leads to multiple operational mistakes and increasing risks. Microservices have been represented to the industry as a way for speeding up software development in comparison with traditional applications. So, the monolith applications of the past supposed to be decomposed into the small number of applications. Each one of them created around non-decomposable anymore business functions. In this process, a lot of attention was dedicated to convenience of development to be performed by either an individual developer or by a small team of developers. It seems that the creator and proponents of this development style either did not really figure out what they do, as Martin Clover admits once, or they simply didn't care much about the business values. The matter of fact is that business operates only with compositions of small tasks. That is, microservices have to be recomposed into applications again. That part is usually omitted in the discussions about microservices. Microservices actually require more microservices in combination back to the application require actually more efforts than one person or just a small team of developers. But rules of and principles of such work are totally neglected in the microservice architecture. In business, many functions have to be executed in certain order. This is how many business domains work. Decomposing monoliths into individual small pieces of functionality or microservices loses these orders or process logic. When we emulate business actions, functions, or processes via microservice, we do not know why one microservice has to call another one, or why one microservice has to fire events for others, or look up for events in others without business logic across them. As a result, the business practice stated for microservices and the best practices stated for them are actually appear as an anti-patterns from the business perspectives. The sequential invocation of small functions in business is known as a functional transactions. Thus, either we preserve unrealistic from business view principles of microservice architecture and its best practices and do not use microservices for solving many transactional business tasks, or microservices must work in transactional where needed behavior, irrespectively whether developers like it or not. The microservice development principles that oppose transactional behavior should be relaxed if we choose to use microservices for these purposes. Microservices are not only independently deployable units of work. They can be freely distributed and have individual ownership and life cycles. And this is absolutely new notion for developers familiar with object-oriented development. Therefore, if we use microservice, we have to deal with distributed transactions across ownership boundaries, which are quite different from monolith transactions within the monolith applications, as well as from the operations of autonomous microservices. Particularly, transactions are not only sequential activities. Some of them are conditional in groups of activities. That is, either all A, B, and C functions in this example take place or none of them. The implementation of those conditional transactions is known as two-phase commit or 2PC. In a distributed environment, 2PC is either very difficult or impossible because it locks the participant state to roll back all performed actions if one of them, like this function C, fails. But due to multiple ownership, locking is impossible. As a result, we have found numerous recommendations to avoid distributed transactions for microservices altogether, instead of finding proper solution. Furthermore, developers have found another reason for avoiding distributed transactions in microservices world. Modern perception states that microservice implementation does not need to be precise and unflawed because the major value is scalability and performance. That is, it's okay for a microservice to fail. Well, next time it will work. It is a classic mass media behavioral pattern where the content is less important than involvement or distribution. Apparently, our society still vitally depends on the concrete content of high quality, including solid transactions. Social media development habits and eventual data consistency associated with distribution are not and will not be standard for the rest of the world. Consistency and accuracy of data is not a trade-off for scalability in many industries. We need both and desirably at the same time. Just imagine failing transaction in software for ATM station, aircrafts, ships, trains, cars, and your finance. Yes, eventually we survive, but it is because the systems are tripled and quadrupled to protect us from clumsy software. Thus, we have a choice, either to eliminate microservices when programming digital transaction in distribution, distributed digital transaction, for instance in finance, or we have to learn how to use microservices in the most reliable way. If such development requires efforts of more than one developer or a team, it has to be so, and DevOps should accommodate such line of thinking and appropriate automation. Following parts of that presentation we'll discuss how to build such reliable distributed transactions across microservices. But for today, it's all. Thank you very much for your attention and hope to see you next time.